red light, red light, red light. How do I look? Pretty good. Spin it around. All right, so this is long overdue, but we are going to build a 3D flight lab. This one is printed in red, white, and blue. Got a little touch of gold for fun, which is going to be our centerpiece. We also have our carbon fiber to kind of really make this thing pop. Should have done this build a long time ago, at least on video. We've had enough evolution of it and try to keep innovating that we always haven't kind of had a stopping place almost to stop and do this. So anyway, we're drawing a line in the sand and making time right now to get this done. This is version 1.4 and we're really excited about it. So this is of course Chaos Cloud. You can check us out at chaos.cloud online. And then this is a little different brand we have. We manufacture this for Binary Box, which is just another kind of sister company of ours that focuses on kind of consumer 3D printing drone tools. But the name of this actual product is called 3D Flight Lab. So totally printable, designed to be printed really on a traditional consumer printer, normal build plate style. So pretty much anything you can get off the shelf should be able to print this. We tend, you can print it in PLA, you can print it in PETG, you can print it in ABS. We tend to print in ABS GF, and this is more specifically mostly from Bamboo Labs. We do that just because it keeps kind of a consistent color palette for us. We also like the texture of the GF, just a little different product. We don't have any problems printing it. PETG works just as good. If you're gonna keep it kind of at home on your table, you know, PLA is probably fine. When we sell both these digital files, the STL files for this kit, as well as pre-printed kits, kind of like you see here. So we would, you know, print all these in the color of your choice, mail it out with all the hardware and everything, kind of with a nice bow on it. So when we do that, we've had these go all over the world, literally. And surprisingly enough, we originally kind of focused these towards the consumer. We've had a lot of interest in universities and just education worldwide. So which is super awesome. We've got some collaboration with some technical schools, with you know, all sorts of different students, from just, you know, your normal hobbyist or drone nerd, all the way up to your, you know, kind of educated professional that does all this fun stuff for a living. So, and you know, we've spent a few years on this. We've worked hard. We're proud. It's really well engineered. That doesn't mean there's not room for improvement. We find mistakes. We find ways to streamline hardware. We find all those things. So we have a Discord. It's in the instructions, the digital files that come with your 3D Flight Lab, regardless if you bought it digitally or a kit, you still have those files. As we update things, you have free updates forever for the life of the product. So, you know, as we fix things to do that. But anyway, bottom line is give us feedback. If you're like, hey, you know, this is a problem, or hey, I got a good idea, like, please share it with us. You know, we're trying to make it accessible and all those things. We charge a little bit for it, but really it's just so we can kind of keep putting money into it. And, you know, we're definitely not getting rich off it. So anyway, there's a couple versions of this. One is all printed. One is carbon fiber for kind of more of a modular effect where you can make it bigger or smaller. But again, we kind of stick with ABS as we went to mail these around the world. We've had them, you know, PLA and stuff. We don't know where these go, right? They go in a black hole when you ship them. And whether it's gone just across the US, a few states away, or all the way around the world, we've had them get warped in PLA. So we originally did some PLA carbon fiber from Bamboo Labs. And I don't know what happened to the package in transit, but it was like, so exposed to some conditions we didn't want it to. So we haven't had that same experience with ABS and PETG. So we kind of just went that safer route. People want to move it around, put it in their car to get to the field. You can do those things, take it to a friend's house, whatever. You're at less risk for kind of that heat threshold. So anyway, so we're going to do the bigger modular kit. It's 3D printed. This is ABS GF on these two, on the red and blue, all Bamboo Labs. And then in the middle is just straight ABS from Bamboo Labs. I haven't built this exact iteration yet. We just made a bunch of changes. So yeah, we're going to hop in and get going here. But before we do, I kind of want to throw a few tools out there. There's heat nuts that come with these. You can buy these things floating around Amazon, all those places. It's just, you know, fancy soldering iron. They can put it down and insert your heat nuts. The nice thing with this is, at least this style, it doesn't have to be in this frame, or this fixture, but to have the controllable temperature is really nice. Here are kind of some of my favorite tools. These little gasket tools, of course, you know, your nips, and then I got kind of a pokey tool. We do have these instructions I'm going to kind of just go off of on my iPad, but the new ones for 1.4 green, they may be, depending on when you watch this, it may vary. It's kind of how we help it kind of slap you in the face and tell you what color it is or what version it is. Yeah, there's pretty much all the step-by-step instructions in here. So this is what I'm going to be using to put it together, even though I've done a bunch of these. Again, this is a little new variation, so I'm just gonna kind of check myself, and allows me to kind of validate the instructions as we go. But should be a pretty cool red, white, and blue color scheme, carbon fiber accent. And I'm gonna go for, usually what we do if you buy the kits, which is 3dflightlab.com, where you can buy this stuff. 3D Flight Lab, so the number 3, the letter D, and then flight lab.com. We sell these just a hardware kit, so if you want to print this at home yourself, but you don't want to go and like click on every link and buy every heat nut and screw, and we sell just a hardware kit. We sell just the printed kit, and then we sell the printed kit kind of with the carbon fiber. So there's some mix and match options out there. But anyway, what I'm going to do is just get into pulling the supports off, and then we'll speed through that here quickly. All right, I'm gonna go ahead and plug in the old heat gun. While we do that, I'm gonna skip around a little bit because I guess I'm cool and I can. So that'll be the first heat nuts we do, 3x4x5. And then we also we use these little standoffs like you'd use on a computer. You need 4 of them. They're these just little gold hexagon 12 millimeter length things. And at first we were putting heat nuts in these and moving things around, and it just got kind of like awkward to get everything lined up. So now we just use these, they slide right in, and we can thread our screws in from both sides that way pretty easy. So these just push in, and of course that one just fell out. Like I said, they slide right in. No blood, no foul. A little blood, but don't tell anybody. All right, and then next, these are just slotted, these base legs, so they just go ahead and slide right on top. Let's kind of do this, like this. That's really about it. So you got it put together that quick. And we'll do 3 of these in the center of the base here. These are the M3 by 4x5 heat nuts. Be very careful if you do it the way I do it. So anyway, yeah, let that cool down. While we do that, we will go back and we can put in our screws on the base. So these are M3 by 10. You'll find pretty much all the screws. Oops, if I can read. There we go. There's 1 bajillion of them. M3 by 10. Find my handy dandy screwdriver, or Allen wrench rather. And what we usually do is just throw 1 screw in all these. Pick a side and just kind of go, you can go clockwise, go counterclockwise, whatever you think. You can put them in both sides if you want. But totally up to you. I think for this purpose, we'll just do both. These are M3 by 10. They kind of just go, right now I'm going one direction, and then I'll just flip it and kind of get it rolling the other way. I think we're down to our last one. So that quick, we've put in what, 4 standoffs and 8 screws and 3 heat nuts. So moving right along. So that's our base. I'm gonna go ahead and set this in the background just so we can keep doing this stuff. All right, so now we want to put this one, it's kind of our centerpiece for that base we just assembled. So that's I'm trying to go red, white, and blue. And so trying to keep those colors touching for fun. So this one's gonna have an M5 heat nut in the middle. So we are going to freehand this bad boy now. She's a little bit bigger than we were planning on, but we got mad skills, so we're just gonna make it happen. Ooh, I gotta say, that looks perfect. All right, there you go. 5 by 5 by 7. We won't tell nobody. We're gonna take this and it's gonna slide right in there like that. We of course want to line the holes up in the white part with the 3 holes in our triangle shape in the base of the red part. And these are going to be our M3 by 10 screws again. Again, be careful not to touch that part. That one holds a little more heat than the rest of them, that big M5 heat nut, so that won't feel good if you get your lips on that one. Back to our instructions. Let me get rid of this guy again for a second so we can stare at big blue here. Okay, so heat nuts again. So M3 by 4 by 5, 3 by 4 by 5. When it's extra hot like this, I actually don't like it as hot. Again, I'm not really doing fully what I'm supposed to here with my heat gun or my soldering iron. Just turned out pretty good. And we're going to go M3 by 4 by 5. So we're going to go on the sides now of all these guys. So this is where we help kind of screw our ends together. This is one of the big design changes we had, and we had a few of them, is coming into these parts that hold the tubes together. It's been one of our biggest stress points, and a place where, whether it's design error or user error or both, where we've had one of our biggest failure points. And a lot of times it's not even from use, right? Like from having your drone and using it as a test bench, but as like just assembly, right? Like if you kind of don't just kind of like torque it down correctly, which is really easy to do, it will, kind of crack, which isn't a good way to start off the build. So we've changed the design a lot so it doesn't do that anymore. But it's a little bit different process of tightening the tubes now. So that's one big reason we wanted to go ahead and do this video as well. Aside from these are just exciting to build, but all right. You guys are making a big old mess. Oh man, it's so close. I don't quite like it though. Let's see. There's a little gap right here, and you can actually. There we go. I was gonna say it's just a hair of a gap, but I don't want to put tension on it. So yeah, if you look right here at the bottom corners, you can see that gap go away, and that's a good indication. This isn't going to be totally flush with the top, and the reason why is because you have this other piece, as you see, it's kind of different depths and it's keyed. So this will actually set that and kind of fill that offset. So the top of this is not supposed to be flush. So what you're looking for is these bottom corners down here to kind of come together. Right here where my pointer fingers are. Okay, we got it. Okay, and now M3 by 10 again. Seeing the pattern here, M3 by 10. So we need 4 of those guys. 1, 2, 3, 4. See if we get these started, and we're going to be doing good. So you might be asking yourself, you know, or saying to yourself, hey, this is pretty cool. You also might be saying, why do these guys make this? Well, because we were building drones, and if you look around, it's kind of hard to tune them sometimes, and honestly, assemble them. You know, it's if you're doing a little FPV drone, I mean, it's pretty easy to throw on your workbench and, you know, solder away. But if you get some of the little bit bigger things, and I'm not talking like, you know, size of a school bus here, but bigger drones, then it helps you to do that. But the biggest thing is, like, you know, you can call it a safety pitch, or you can call it for tuning. But really, when you get into the props and trying to do all your drone tuning, especially for custom built, or even, you know, putting new props on for the first time, even on a store-bought one, you know, did you put them on right? Are they going to take off? Did you? There's just a lot of ways, like I said, not only for safety, but just peace of mind. I mean, it's a big investment in a drone, you know, and it's a good way to be able to test what you're doing before you go put it up in the air and a prop spins off, or, you know, something like that. You cut a finger or any of those things. So consumer drones, less likely to hurt you, but still can. Some of the things we play with, I play with and you play with, are kind of going from hobby to pretty serious machines. So yeah, and again, get them snug. Their heat nuts set in plastic, right? So let's not get too crazy. Just snug them up. But there you go. So we got that guy. That's what it looks like. Looking pretty good, right? You like that color contrast? I like it. Okay, now we're back to this piece. Remember I said don't freak out if this isn't flush. It's not supposed to be. And this guy is going to go right on there and sit in there. Now it's flush. Okay. Moving up on our directions here. Up, up, up. Okay, and we're going to need one bearing in here, which is our 51103 bearing. 51103. So this you can get on Amazon, you can get it from us. Doesn't really matter. You get yourself a bearing, and that guy is going to go straight in the center there, like that. Right in the center. Okay. The next spot, and this is a spot we're still need to work on a little bit, to be honest. Let me go grab the stickers. So these stickers, which are really nice stickers, but they don't always fit kind of perfectly on our part. So this hole was originally supposed to be cut a little bit bigger. So what I do is come back in with a razor blade and just trim off the part that's not supposed to be there. The sticker goes on the center circle, just like that. This is the part with the two little nubs on it. Then you just feed those keyed parts right into where they go there. Okay. We can put, I missed a little support here. There we go. Make sure you center that in the bearing. You get a nice little rolled lip right there with the sticker. So it's kind of two ways to do it. Either trim it, or you can roll it under a little bit. It'll work out fine either way. Okay, back to get our base back now. See if we can make some room here. There we go. I think that'll work. Okay, so we have this big bearing, outer bearing we need to use, which is 51108 first. Now, you know what? I might have one that's open. Let me go check. Ha. So I just happen to have one laying around, so I'll save that one for somebody else. So the 51108 bearing, and what's important to remember on this is there is, the bearing has, even though it looks equal, one of the sides has a little bit different diameter. And you can actually feel it if you feel. You can feel which one's bigger. Usually I'll do that on the inside. So the 42 millimeter side has to go down. And that is on mine the one that has the markings, which has the 51108 and the XC on it. I can do that by tell by feel. That goes face down, so the lettering goes down. Okay. Now we put the base on. And this is going to be a tight fit. So let me start over with our little process here. Kind of got ahead of myself. So we had that bearing on. This one's like that. And now, with some pressure, we're going to get this seated on there. And it can take a little bit of moving around here to get it exactly right. So this will be our M5 by 25 screw. I usually use a little different size of screw, but again, this is one that just came out that we're just building, so we're gonna roll with it here. So we'll do our M, just kind of reiterate here. So we'll do our M1108 bearing, put that on. If there's a larger inner diameter, it goes down first. And then we put our base on, put our M1103 bearing on, and then or 51103, sorry, I'm getting confused here. 51108 bearing goes down first, then 51103 bearing, then our cap, then our screw. Anyway, it's all in your instructions here. So yeah, and check for free rotation. And pretty good rotation there, so. Okay, when we have this screw tight, we want to make sure it still rotates. Just, I mean, it should, but you know, make sure there's no play left to right. So we need to tighten it a little bit more. Let's see. I think this should be about just right. Oh, getting there. There we go. A little sticky still. A little sticky still. Body weight usually gets it seated good. There we go. Nice and smooth. So kind of see the process to work through it. Found our screw we were missing. Put that back for later. So there you have it. Kind of have everything put together there. And the next spot is, I did gold one, just kind of a nice cool centerpiece. Pretty cool, right? But we're gonna add some magnets to the back of this guy. And these should be the 9 by 2.5 millimeter magnets. They say 9 by 2.5 when you order them. Just make sure the diameter is 9. Usually what you're going to end up with is 9 by 3. And that's the 2.5 is kind of an accurate representation of what you're getting, but that's not what they list to order it on. So anyway, so the first thing I kind of do here is kind of check the polarity to see which side sticks better. They'll stick pretty good to the base here. I would say that side sticks tighter. So I'm going to use that. I'm going to take that. I'm going to put these 9 by 2.5 or aka 9 by 3 magnets into our needle here. So idea is to get your 3 magnets in here, and then this will be magnetic. So as we spin our thing, keeps us going there. So pretty cool. Nice little gold touch, red, white, and blue, the spot of gold. All right. Next, we're on to the yaw axis. So what I need to do now, what I wanted to show you is you can, of course, use the printed pieces, the printed tubes, which are more of a hexagon, or you can hop in here and do the carbon fiber tubes. These are 16 millimeter external diameter. Sorry, start that over.
And action.
These carbon tubes are 14 millimeter external diameter, 12 millimeter internal diameter, and these are 500 millimeters long. That's generally what you're going to get. We do that because you have options when cutting. And yes, you have to cut, wear a respirator. You don't want carbon fiber dust because it's no good. So do make sure you can cut these a lot of ways, but make sure you're protecting yourself with the appropriate safety stuff, and especially eyes and respiratory. So what I'm going to build, if you look at our instructions here, you'll see we kind of have 5 sizes detailed out for you. These bright yellow ones at the bottom, these are ones you can build, but they're a little more unstable, right? We get bigger drones, more weight, more leverage out there. So possibility, depending on your size, kind of wingspan, what you're building, and its weight really, and what you're planning on doing with it. But these ones in these dark areas up here are kind of the more stable sizes that you want to play with. My drone in particular, I want to do I have a DJI Matrice 4T that I want to put on here for fun. So I think looking at the diagonal span of it with the props on will fit within this one we have here, which is the DX size 750 millimeters. So I think it'll just fit inside there. It's at the kind of the maximum height or maximum dimensions for our kind of stable drone package, if you will. So I'm going to go for that, the 750 millimeter. That's what we're building. So I have to cut these carbon fiber tubes from 500 millimeters down to size. So my yaw axis, I'm going to go 368 millimeters times 2. My pitch, 360 millimeters times 2, and 326 millimeters times 2 for the roll axis. So what I've done on these is you can mark them with the silver Sharpie and things, but I actually found a chrome pen, which is pretty cool. I think it got it on Amazon, but it works really good. I don't know if you can check that out, but it works really nice to mark these guys. So that's what I use. By the time you get your, glasses on, you go to the saw, starts fogging up because you're heavy breathing, you're excited, whatever. It gives you kind of a really good visual guidance line there. So that's the plan. We're going to build the 750 millimeter DX size. So we're going to cut our 6 500 millimeter tubes down to these 3 different sizes. Again, you need 2 of each size. It's not quite clear in our instructions here, but we're gonna kind of fix that up a little bit. So I'm gonna go do that. We'll be back and we finish assembling this. So put in some more heat nuts. We should be able to pretty much button up the build here and see how it looks. We got a new air filter. So I'm really excited to, turn my filtration on in the room. If I can remember where I put the remote. Maybe in my pocket. Maybe. Oh, nope. Keys. How about this box? Man. Where? All right, so I'm gonna put my magnets away. We got our carbon fiber cut. Excuse me. I don't know about you folks, but I just have one of those 3M face masks, and it has the filtration. It covers my whole face. I just slap that on, and I'm done with it. So I don't have to worry about everything else. It's in my fingers, I guess. But you'll see here, if I line them up, got 3 different sizes. Let me do this a little different way, just to make it look cooler, I guess. Holy cow, that's funny. It shook back out the same way. There we go. So you can kind of see there. Whoop, perfect. Okay, so you can kind of see we got our shorts, mediums, and then a little bit taller. So these you're gonna have 2, 2, and 2 for your different axes. So make sure and be aware of these if you're not using the 3D printed parts, which you totally can. But if you're going carbon fiber tubes or some other crazy material, just be aware of that, because we've had, like, just on occasion, people where we 3D printed the parts, they're labeled, it's embossed like into the part, but you know, they just get confused or they're excited and they put them together and it's like not symmetrical, right? It's like, so and it's in that instance user error. So just be aware that there are 3 sizes this way if you do the tubes, and you need to cut them different sizes for everything to kind of jive. You know, be as accurate as you can. I mean, but I'll tell you from experience, these are going to slide inside here, you know, quite a ways to capture a good point of the tube and kind of clamp it down. So you have a little bit of forgiveness. I mean, if your cut's not like, you know, beautiful, like, we're going to hide it. I mean, you know, make it as pretty as you can, make it as accurate as you can, but, you know, don't freak out if it's like a little bit off, because these tubes are, you know, they're expensive and you can get them all day on Amazon, but they also, I prefer the matte ones. I don't know why, I just do, versus gloss. So, you know, if they take an extra 2 days to get here, and we're getting impatient in our old age here. So, all right. So next spot we're going to do, so this is, we have yaw is going to be our longest ones. So let's do it like this. Yaw is our longest ones for our build. And then second longest is the pitch, which is these. So we're going to put pitch up front. And then we're going to put the roll axis in back. So for the yaw axis, so for our yaw, we're going to go ahead and we're going to put these guys in here. And that'll be our spot. Now on this guy, we already set the heat nuts in here. So our next spot is to just kind of take our little clamps and then put these on. We've had, these have been redesigned a bit, and our style of clamping tubes, as I mentioned earlier. And, you know, this is one of the kind of maybe the kind of weak spot right now as far as instructions in our assembly, because people tend to crack these or do things. So we really try to focus our print orientation. If you have a bamboo printer, great. If not, you can do this without it, but we pre-lay out our plates in certain orientations. And we also have pictures of the instructions on these. So if you don't have a bamboo and you can't take advantage of the plate layout, you can still come back and see how we like orient these parts on the print plate. Because, you know, print orientation does matter. You don't want things to delaminate, and you want them to be perpendicular to kind of the point of stress, right? So these guys in particular, we print at like a 45-degree angle, there and about. But you just kind of want to cinch these down again, kind of like a car wheel, where you're like, you work it down, you work it down, you work it down, you work it down. Like, big thing I want to point out on this is people feel the need to like, this has to like not have a gap and be like totally flush. These are designed to clamp down, and so when it's clamped, you might not have aesthetically this perfect, like, you know, flush mount. You might have a little bit of gap, and that's to give us that tension of pressure, right? Like, we don't want like too much play, and we don't want it over tight. So that gives you, the user, the ability to adjust that in different, you know, humidities, climates, and tools and all these things. So we just really want you to have the freedom to be able to get it cinched down just right. So what that means is like we have a little bit of travel here, and so you may have a little bit of a gap, right, when it is the correct tightness. So just be aware of that. Like, use your judgment. Like, get it snug. If you're going to tighten it down more just because like you want the gap to close, like, you might break the print, right? So just use your best judgment. And if you break it, we'll mail you some more because we're nice that way. But, or you can print some more. So not the end of the world. That's what's beautiful about this. So, all right, let's get back to doing something cool here. So we're going to get this placed in here. And see, they fit pretty snug. I mean, the tolerance is good. Look at that. I mean, can't yell at me too much about tolerance. We can yell at Hovey, but look at that. Man, woo, look. That's just like sitting in there. I got nothing. You got nothing. That's awesome. So you see the point. This is just securing this in there. So let's get it. Let's make it hold it in there. Let's not like show how big our muscles are and snap it in half. There's a couple ways to do this. The instructions, which I'm obviously like coloring outside the lines here a little bit. The instructions say we should start with our little arms here. So these are the B2S arms, and we're just doing the same thing here, right? We're gonna put the one end in there, and look at that, sticks beautifully. So get it situated down in there, and then these are the parts we're also gonna put the heat nuts in, right? So just like we did here on the blue parts. The other thing we need, so why are heat guns heating up? Our little arms here, we want to take and put our bearings in, which are the 608 bearings, and we're gonna do one in each side of these. So we're gonna come in here, pop one in like that, pop one in like that. Perfect. Okay, we got two of these guys, so we're gonna come over here, and I'm gonna shake out a couple more here. Two more. Come on down. All right. So you can see how good these tubes fit. I mean, kind of throwing it around here, and shouldn't have too much trouble. Okay, so we got our 608 bearings in each side of those guys, and then we're gonna go ahead and put our heat nuts in these main arms here, which are gonna be M3 by 4 by 5s. Kind of checking everything we got going on here. Like I said, this is a new version update for us that I'm building, so seeing little things we can improve, things we can tweak, trying to clarify, make sure I know what I'm talking about, you know, all those fun things. When you set these in too, again, go just to where it disappears. I've been guilty of trying to push it in, you know, too fast, trying to put too much pressure, but just let it melt in there. It's a stronger part for it, and if you push it in too hot, it just makes a mess. So got it all beautified right there. I'm gonna grab two more out of the bin here. If you get these, I took my inspiration from it, I'll admit it. Persa, I don't know if you've Persa 3D printers, if you ever built one of their printers, their kits, but they have really cool, they always done a really good job of labeling their parts. It's like the biggest compliment I can give them. I've built most of their printers, at least their consumer level printers they have, and I've always loved, I just say this till where it's annoying, but I love how they label their stuff. They put spare parts in, and they actually say they're spare parts, so people don't freak out and wonder, why do I have an extra one? Why is there two extra ones? But pretty much everything they add an extra part. So we haven't got to that level of coolness yet, but we are we do baggies, we have labels, we write on what the part size is, how many is supposed to be in there. We will occasionally include extras, especially on certain parts, but we're still getting there, so bear with us there. But we're trying to kind of follow that path of, you know, labeling, which is cool. So all right, we got our bearings in, we got our heat nuts in, and now we want to let it be a little bit. Let's make sure I grab the right parts. I got parts everywhere here. We want to make sure these cool down a little bit. As you may or may not know, depending on how much experience you have with heat nuts, if you get to where you're putting a screw in too fast, you'll actually just twist it. It hasn't fully kind of re-solidified in there. It's a little bit gooey. So, but this is what's fun. If you print it yourself, you know, or you get a kit from us, you can mix and match. But I mean, pretty good, right? So you see what I mean by the screws? Like, you know, don't go crazy on these things. And that's like where you get people who are just like, crack. And it's like, man, you know, you didn't need to do that. So, all right, I'm gonna double check my screw size, which I already know what it is. M3 by 10. That's usually the safe bet, is M3 by 10, but like I said, we've made some updates, so some assuming has got me in trouble already in this build. Try to assume what we've had from the prior builds is the same, and it's not. Probably will come back and replace this one part I did print in ABS here. these white connector pieces are a little bit kind of goobered up. You can kind of feel these take shape. See, there's still a little gap there. So that one grabbed. I can feel it. It's kind of pulling down. Went for another screw like I didn't already have one in here. Whoops. Go. Yeah, I think I'll probably swap these out. They're a little bit, I don't know, it's kind of, maybe we need to dry that filament a little bit or something. A little bit of, there we go. Gonna get it down there and get it started. Yeah, this one had a little bit of extra, like, kind of gooey around the edges here. So again, the point is to clamp, right? So let's keep that in mind. We're clamping this. And it still may have that little gap. Which may drive you totally crazy, but this thing ain't coming out. We've already distributed that. So that's just to give a little bit of range of motion again to, you know, whatever reason, whatever variable, whatever environment, whatever print, like you just have some range of motion to do it. So don't feel the need to totally flesh that out. There's a lot of variables, so we're just trying to accommodate all of them. If you tighten it all the time in every build, like there's a good chance you'll crack this. If you want to print these with like, you know, 8 walls and go nutso, you probably won't, but knock yourself out. It's on you, it's your build. Another thing I want to say is on these you'll see, you know, they have the kind of the part that's part of the arm, let's call it, and then you have the cover, the cap, right, the clamp piece. That's a totally wrong one. That comes on and sets down on it. When you do that, I try to keep all these the same way as you go around in that plane. Keep them the same way. I mean, it's kind of silly if, like, you know, you start mixing and matching which way these caps are going. Just kind of like pleasing to the eye, I guess. I mean, do what you want, but I try to like keep everything oriented the same. So see how these are open here? I'm going to try to keep, so I'm going to put this guy here. Yeah. Just to kind of keep that system going, right? Okay. Make sure I might have printed. Did I print the right caps? I think I printed the wrong caps there. Did I print the right caps? Right cap, wrong cap, right cap, wrong cap. I feel like I did too. So I printed the wrong, well, the right caps are the wrong color here. Because we need this bottom piece has thicker cap. Yeah, which is that one. So that's going to be red. So I need to reprint these in blue. So I got those as red. So I'm going to do that. Noob move. Amateur hour. So I was like sitting at the computer and trying to be like, oh, what touches what? You know, I'm trying to go red, white, and blue. So anyway, screwed that up. I'm going to reprint these, but we'll be back and unplug my soldering iron so I don't smell like chicken in here when I touch it later. But we'll come back and we'll finish this out. You didn't see anything. But reprinted these parts here, and we're going to come in and put these where they go on here. So I'm going to spin this around out of view of you. There's a slanted portion on here. So again, we're doing the M3 by 10 screws. There's a slanted portion on these blocks. You'll see kind of a square side and a slanted side with a little bit of a taper to it. So with the taper to it is the one that goes on the inside like so. Basically, if it feels right, it's right. If it doesn't, readjust till you get it kind of squared away there. You over tighten it, it'll crack. Gotta reprint it or send a real nice email and we'll send you a new one. So there's that one. And we put the screw in up here. We did. Okay. Double checking because we took a little break, so I want to make sure I did what I was supposed to be doing. So again, kind of the beveled part there goes in. We're not expecting it to clamp entirely all the time on every build. That gives us that freedom to adapt and overcome different parts here. That's all you need. Again, line these up to where you have that shape is not symmetrical. So get it where it sits in the correct orientation. And again, right, pretty good. So it fits good. So let's not overcomplicate it. Beveled side is going to go down towards the main arm. M3 by 10. A little better angle here. You can work it back and forth like anything else. You tighten one side all the way down. It's going to really limit what you can do on the other side. So, and just dug. There you go. These guys, you can see we can kind of square them up a little bit. Going perpendicular to the rotation here. Kind of line them up. So a little crooked still. Bring it in a little bit. This is going to kind of self-correct as we put it together, but that's looking pretty sweet. I mean, I'm just saying. Okay. What's next? I'm glad you asked. Let's open our handy dandy instructions. Back over here. And let's see, pitch access is our next longest. And where are we at? Oops. Oh my gosh, where are we going? Well, that was accident, but let's check it out. So we do have an assembly tip PDF, and kind of what I've been stressing about assembling these pieces here and just kind of working it together. There's a nice little PDF here that kind of shows you what to do and what not to do. Not to close the gap all the way. You don't have to close the gap all the way. So don't be that guy. I'm just saying, don't be that guy. All right, where we go? So where are we going? Where are we going? Where are we going? Let's see. And there are different adapters to make different plates for your drone to mount to that come in the kit or that are printable. And then you can actually get different size tubes also. So these are 14 millimeter external diameter, 12 millimeter internal diameter, and 500 millimeters long is typically what you get with your kit if you purchase from us. But you can do different sizes. I mean, we have everything here from 6 millimeter, all the way up to 15. So if there's something, you hop on Amazon or Alibaba or whatever, and there's something that's you can get the next day or it's cheaper or whatever, or that fits your application better, you can do that. And then you just use little different adapters. Here we have that slide on the end of these tubes, and that interact with the arms here on your axis. Okay, let's see where are we at? Where are we at? Where are we at? Okay, we're done with yaw, and we're on to pitch. So pitch is where we're going to do our whole ring. Now the narrower pieces, which are in our case red, are going to be the ones that are going to connect up here to our yaw. So again, we're going red, white, and blue, which kind of helps the instruction on this thing, but that's kind of how it works. You can see the two different types basically, right? See, this one's a lot wider webbing, has this huge hole in the middle. This is going to be the part that is out here on either side. And then this part with the narrower webbing is going to be the part that you're going to have against your yaw axis over here. So we're going to start with really any of these parts, but we need to go ahead and throw our heat nuts in all these. So I'm going to go ahead and do that really fast. M3 by 4 by 5. We don't want to smell chicken fingers, so be very, very careful. So we want to find A1 LW, which are going to be our blue ones here. And we're going to go back to our bearings, and you get a bunch of these bearings if you buy the kit from us. But these are the 608 bearings. And each one of these is going to have the bearing on the outside. Again, you can just put these on with your fingers usually. You don't have to get too wild. Sometimes I'll go back to using those smooth pliers, adjustable pliers, but not usually necessary unless you're getting really crazy. which, you know. Okay, so that's kind of what you got there. You got a bearing with a 608 bearing on the inside. You got a 608 bearing on the outside. So we're going to repeat that. Okay, and that completes those two ends for us. We have both our heat nuts melted in, and then our bearings inner and outer, if you will, or outer and inner. So to plan this out a little bit here, because we have two different sizes of tubes. I'm going to lay this out and just make sure got kind of everything the way I want it. Make sure it makes sense. Holy cow. You can see this is a big build, running out of room for activities here. And some of it is positioning on getting your tubes rotated, kind of getting everything squared and set. And as you start to put it together, it'll be a lot more obvious here how it comes together. Doing it on a flat surface really helps, because that way you can keep everything kind of square to the floor, which I might need to take advantage of here if I can't get myself together. So you can see, like, I rotated this one down. Super windy outside, holy cow. So let's see. Make sure all your tubes are seated fully in each arm. You'll see the rotation I'm talking about. So what's nice is when you get these set, you should be pretty good that way, especially if you do it on a table like this. You can kind of make sure, or on the floor, honestly, half the time it's better. You can kind of make sure everything's just pushed down, or a workbench. Make sure everything's kind of pushed together. Make sure it's tucked in. Push together, push together, push together. My work bench here is kind of interesting how it sets. I have a flat spot, but then kind of a stair step down. So kind of rolling with the punches here a little bit. And let's see. Taper part towards the main arm again. Taper part towards the main arm. Been on, got a bunch of printers going in the background. And got a print going that's been going for 3 days. Yeah, over 3 days. And all of my printers are on surge protection and battery backups, except the printer happens to be doing this huge printer, or this huge print. And why? Because it's always been printing every time I went to install the battery backups, or I thought about it. And so coincidentally, this one's on. Now there's a huge storm, and we have a lot of trees around here that always tend to knock the power out. So I'm really shocked. At this point, I'm not worried about jinxing myself. I'm just shocked that the power hasn't went out. So, all right. The blue one, and then I got to print one more red one. And as long as we have power, we'll come back and we will finish this up. We're back, and we're going to try to hopefully get this put back together, or finish putting it together rather. I'm going to get these screws kind of started but not poking all the way out. Again, the bevel side is going to come into kind of our center. We can push it in hard there and kind of make sure we get it tight. Like we're lining up perfect. I think we're lining up perfect. How we doing? Pretty close, pretty close. I think. Kind of been fighting this one screw here. I thought it was the printed part that I reprinted, but we'll see. It might not be. Man, I just snapped that part off the arm too. That's nice. Struggling with that part today. All right, let's get this one done and we'll move on. For some reason, I'm gonna have to replace that piece now because I just snapped a piece off. So, here's what it is. Make sure this is seated all the way. That there. That one started. That one started. Haven't had problems with any other ones other than that one screw on that one side. It's been a difficult booger. So I'm gonna work this back and forth. We're gonna replace that whole section over there, I guess. So, and now you're gonna find these little pieces. Anyway, the next thing we want to do is making sure squeeze these guys in here. Okay, make sure those fit, and there's kind of a shoulder you'll notice on these. Let me get a pointing tool. So there's a little bit of a shoulder here. So you're only going down. It's again not going to be flush. So I think it's like this human nature to have this perfection in us. So like, oh, there can't be a gap and this has to be flush and all these things. So there's just a little bit of a shoulder. So there is supposed to be a little bit of gap there. So you just want to get it set down all the way to there. And then after that, once you hit that point, we're calling it good. So now for us, it's the narrower webbing that we're going to put on here, okay, on our yaw axis. So our pitch is going to meet our yaw axis like that. The ones with the bigger webbing right here, these are the ones that are going to hang out later for our roll. So we're going to sit out like that. And again, I intentionally did one of the red whites to kind of connect that way. So that was my plan, even though I had to reprint some parts a bunch. Okay, and then these are hexagon. So they will hopefully, if you get them lined up, you know, it's like when you're a kid and you got the blocks and the thing. Just kind of slide them right in like that. Yeah, don't make a liar out of me. What's this one doing? Ah, fits like a glove. Okay, there we go. Look at that. Holy moly. Holy moly. What do we got hitting here? Something, a little something hitting. Right. So we got our pitch axis put on here, so it's all snapped in on this side, looking pretty good. And now we have some caps, which are these little hexagon caps. And let me see what size of screws we need. We need the 55mm screws. So these are the really long guys. They're M5 by 55. You're gonna run these through your hex caps. Sometimes they'll push right through, sometimes you gotta thread them. Let's see. What I usually do is kind of run it all the way through that part first, then we'll line it up. So we get it to pop in there. Perfect. Okay, and then let's do the same thing here. Okay, and then we have a couple washers and nuts that go on the back side of this here. Let me get M5 lock nuts, and might need to grab, let's see. All right. And see if we got enough thread there now. we do. Yeah, it should be all right. Especially by the time we cinch this down here. Okay. Again, we just want to get that snug. We're not trying to get too carried away here. That 15 millimeter washer is about perfect though, as far as that goes. Let's see. All right, now we are down to our roll axis here, and let's see, we're gonna have these two parts here. Depending on what size of tubes you use, you'll either have these that go on your ends like so, and hold your tube, which we're using the carbon fiber kit, so we're going to use these big 14 millimeter diameter tubes. You can also end up with other pieces that have just your 6 millimeter thin carbon tube, and then you'll have two ends that slide together. So it's a couple different options, different ways you can do this centerpiece, but we're going to go ahead and do it this way. So let's see how we can roll everything around here, get it all set up for us. Trying to make sure I don't have any more. I think I have a couple more heat nuts I need to throw in, even though I thought I was done. Realizing now I don't. So these little pieces that are going to be our rotational pieces for the roll axis and go into the yaw axis, they're or the pitch axis rather, they're gonna have some heat nuts in the back of them as well. So I'm gonna go ahead and throw those in. I'm gonna need 4 of those, so I'll get those put in. Now we're going to come over here. Trying to burn our fingers because we just put those in. Pretty well balanced. It's trying to lean the way I just put that in. There we go. Nice, nice. All right. And then we're going to use our M3 by 30 millimeter screw. M3 by 30. There we go. So we have 2 of these. We're going to run those in there. That's going to help us just secure this part. Man, all right. So let's see. I think we just need a lock nut on the back side. So this is where we're going to use our M3 lock nuts. Could have, I think, just 2 of those is all that's required. Just about done here. Get our other one started, and then we'll get it all cinched up here. Let's just do this. I'm gonna use my smooth jaw pliers to just run this home here. Okay. Make sure it still pivots. You have to get pretty wild, I think, to get it too tight to pivot, but you know. All right. We're looking pretty good. Now we are going to do what? Guess put our big roll axis in the middle. I don't think this has any sort of. Guess these will have heat nuts as well. Pretty sure these get heat nuts. Otherwise, you can't do anything with them. So if you have these and you're using the carbon fiber kit, you're going to want to go ahead and put a heat nut in here as well. So back to the heat gun we go. We're going to get 2 of these guys. So it's kind of the difference in this carbon fiber kit, and then having these big tubes is a big bonus, but got a few extra steps to do here. And these are the M3 by 4 by 5. There we go. Looking good. Okay, so I've already kind of pre-assembled this to save time before when I thought I was putting in my last heat nuts. So this is an adapter. This is a 14 millimeter because I'm using kind of what we standardized. You can use a lot of different size tubes. You can print different size adapters for these tubes. But here I'm using the 14 millimeter, which is our pretty standard size carbon fiber tube. So that's what I'm going to use for this adapter as well as these adapters on the end. The first thing I'm really going to do is just put them on. We want to get everything kind of just situated, and then I'll come back and snug everything up. And these will slide right on like that. And then we'll have some screw holes on these parts here to keep it connected, and then we'll have set screws on top of the carbon fiber tubes. So you have 2 here, 1 on each side of the top, and then we'll have whatever mounting plate we use, which we're going to use this one, will come on and also mount on here for us. So we'll do that when we get it all put together here. Oh my gosh. There we go. All right, let's get this piece secured so it'll keep popping off on us. Just about done. Holy moly. So I put it on right, that would help. There we go. Cool. These are going to be our M3 by 10 screws again. So we'll need 4 of those. Yeah, I like these Allen heads that pivot. Kind of nice. You can use these access locks. I had that one kind of on and off here as I worked because I wanted to be able to make sure my screw was threading correctly into the heat nut and not pushing it and causing any damage. So important to get them started straight, so make sure that thing's seated all the way before you get your screw going in there. Got that started. Come back. And our current design does not allow, just because most drones don't go beyond that rotation, so it doesn't go in a full 360 that way by design. It goes in a 360 this way. Get this last screw in. I think we made it. Sometimes there's resistance from melting in the heat nut. There's you run into some little bit of filament in the inner threads of those heat nuts, and sometimes it kind of pushes through, and other times you hit a wall and that's it. So if you do too much, you'll either spin the heat nuts in any print, or you know, start cracking stuff and that kind of thing. So okay, we got those snug again. You know, we're not getting too wild here. So we take our axis lock off. We want to make sure these are square, so you can see mine needed a little bit of a twist, so we kind of want everything in line. So both end pieces and then our center piece, we all want those in line so we can put our stuff on here. So next we're going to mount our base plate here on. Okay. And this one, kind of same thing. I usually try to visually kind of line up all the holes first. There we go. I think we're okay. All right. So we got these 4 to put in. And then we have still the ones to help secure our end of our carbon fiber tubes here when we're all said and done. So again, just get these snug. I mean, all we're trying to do is make sure things stay together. Don't got to get too crazy here. Cool. We did pretty good there. Now we have left is these ones on top. More M3 by 10. There are 2 more on the top there. And our adventure. So M3, we're gonna have to go to M3 by 6 millimeters for these, I think. Check it out. Pretty good, pretty good. Still don't have this quite tweaked right. I think these locks are kind of a nice way to be able to tweak it too. So anyway, there you have it. Your 3D Flight Lab version 1.4 is complete. Our red, white, blue, and carbon edition. There's a little touch of gold. So hope you enjoyed building this as much as I did. They're pretty sweet. It's a good way to, again, assemble or tune your drone. When you put it on this base plate, you use, you know, Velcro straps, rubber bands, you know, zip ties if you want to be temporary, but pretty much any way you can secure this. And you can make a custom plate yourself. We offer some like 3 different universal ones. If you have a really cool project, we'd love to help you make one. And yeah, give us feedback. Like I said, this is an evolution. We've been working on this for a couple years, so we want to get you know, every time we make it better. Sometimes we find little design tweaks or things we could do better, or make things more, you know, kind of unified as far as how we do hardware. So yeah, we're working hard to keep making it cooler and cooler. And there's some color combos. You can go to 3dflightlab.com. It's the number 3dflightlab.com, and you can actually customize, kind of order different colors on there. Join our Discord. We're also on all the social medias, so follow us on Chaos Cloud. It's kind of our parent company, but we rock this under a thing called Binary Box, which is kind of our consumer-facing, educational-facing platform for building some flight products. So anyway, drop comments, subscribe, do all those good things. Appreciate you.